Hi, welcome back.
Hi.
Hi. So we're continuing on this writing algebraic expression. You had a couple moments to look at this and try to describe it in words. Here's some of the things that I saw as I was walking around. An equation. All right. Addition and subtraction. Yes, I have an add and I have a subtract. Yes. I also saw add 5 and 7 and then subtract the 12, which I thought was brilliant. It told me what order to do things in. I have 5 plus 7 minus 12. Good. Someone wrote PEMDAS, which is awesome. It tells me what I should use to tell me what order to do the stuff in. Beautiful. Math, and it's complicated with numbers. I agree, math with numbers can get complicated. We'll try to make it as easy and as uncomplicated as we can throughout the course of the year. Okay? So I loved all of those descriptions. All of those are right in some way, shape, or form. Yes, there's numbers. Yes, we're adding and subtracting. Yes, it could probably get complicated as we add more squiggle symbols to it. All right, so let's talk about the objective today, what we're going to do that deals with this stuff. The objectives for you are listed on either side of the projector screen where it says content objectives, written there under the blue paper for you. So can I get someone with their loudest, proudest, biggest voice to read the content objective for us? Go ahead.
I will create algebraic expressions from written expressions.
Beautiful. So today we're going to be creating algebraic expressions. And we're going to be doing that from written, and I'm going to add a word here for you, verbal expressions. And that verbal just means that we've got verbs and maybe nouns and like English things. Okay? So if you'll write today's objective, you don't have to deal with my terrible handwriting. You can look at it on the whiteboard. We're writing today's objective. I will create algebraic expressions from written, and I've added the word verbal, expressions. We're going to be doing that by writing an algebraic notation. You'll see the other objective that's next to it, the language objective, that tells you how we're going to go about creating these expressions today. We'll be writing in our notation. But before we can start writing, before you were able to start writing in like second grade, what did you have to learn first? The letters. You had to know how to write A, B, and C before you could put those together and get cab. I actually did that right. That worked out. Yes. So we're going to do the same thing here in algebra. This first blank is the word variable. And a variable is what we're going to call a letter or a symbol that we use to represent some unknown value. Okay? For example, I've got a water bottle up here. It's mostly empty because I've been very thirsty today. And I can use this as my variable. Because if the bottle were not clear and I couldn't see into it, I would have no way of knowing how much is actually in the bottle just by looking at it. I would have to do something in order to reveal what's inside of it. Okay? And so because the amount of water could change, it's a variable. And so any letter or symbol that we want to use to represent the I don't know how much is there is called a variable. We can use any letter, and that's what you'll see typically used. A, B, C, D, X, Y, Z, all of the letters. Okay? We may even borrow letters from other languages because we're chiflados, and that's what we're going to do. If it's fixed, if it doesn't change, do you already have a word that you use that means it doesn't change? Sure, you're going to let them before they, okay. She's giving you, she's like, I've got this. And everyone's going, tell us.
Yeah.
Go ahead.
It's a fixed variable.
A fixed variable. Ooh. I like the idea of it being fixed. Variable means that it changes. So fixed variable.
A fixed value.
Yeah, it's a fixed value. It's something that's not going to change. Do we have a word that means doesn't change? It stays the same. Too many words. We want one single word. Constant. It's constant. It doesn't change. And so that will be the word we use to represent a fixed value. And it's going to look like a number that you're already familiar with. 1, 2, 3, 4, 5. Maybe it's negatives, -10, -4. Back to the variable idea. The next one says a number used to multiply a variable. Okay? So I've got my water bottle again. That's my variable because, again, I don't know how much water is in my bottle. If I had 400 of these, and all of them had the same amount of water in them, and I wanted to know how much water I had total, I have two options. The long option is I open every single bottle and I figure out how much water is in every single bottle of water and add it all together. I'm bored after the second bottle, right? I don't want to do any more. So the shortcut is multiplication. I'm going to grab one bottle. I'm going to figure out how much is in one bottle, and then I'm going to multiply it by the number that I actually have, which was like 400 in this case. So that counting number, that number that I'm multiplying by however much is in each one, that's what's called the coefficient. Okay? Spelled C-O-E-F-F-I-C-I-E-N-T. Coefficient. C-O-E-F-F-I-C-I-E-N-T. I can use these three things in order to start writing now words in math. Okay, now that I've got my alphabet, my variable, and my constant, with the coefficients now I can make my words. And a term is what we're going to call a word in math. We're going to call it a term. So far, so good? All right. Let's look at this algebraic expression. The entire thing all together, algebraic expression, it's like a phrase in English. So in English, I've got my letters, and I can put together to make words like cute cat as a phrase, and that would be my expression, cute cat. So this whole thing all together is an expression. Each term, each word in my phrase, cute cat, is a word. And so in my expression, each term is like a word. So this is a term, and this is a term. Notice how it's separated by a plus sign. Could also be separated by a subtraction. And that's like the space in English or in Spanish to separate our words so that they don't all run together on us. Let's look at the number 8. What is it? Is it a variable, a constant, or a coefficient? This number 8.
Constant?
Constant, because it's not going to change. An 8 is an 8 is an 8, right? So this is our constant. What's the M?
Variable?
Yeah, it's a variable because I don't know what value N actually has. It's a letter and it's representing some sort of value. So then the number 14 sitting next to it would be what? Yeah, the coefficient, because that's the number that's stuck next to the variable. And what are we doing with that number and the value of our variable? We're multiplying them together. I know there's no multiplication symbol showing there. I get it, but we're still going to multiply. One last thing to see is this plus sign. This is called the operator. It's going to tell us what to do between the terms. Take the first term, 14n, and then do this thing to 8. When you're done, grab your daily work assignment. And we're going to use just that little piece of our notes to complete the top 3. We're going to end this part of the video here. When we come back in our next video, we'll show you the answers to these top 3. We'll be back in a bit.